This conference will now be recorded.
Well, in the last class, we discussed about a connected lookup and unconnected lookup, right? So connected lookup means if the lookup transformation is connected from any other transformation, then that is connected lookup. If the lookup transformation is not connected from any other transformation, that is unconnected lookup transformation. And we have seen we can use connected lookup to return the multiple output values. If there is a single value to return from lookup transformation, then we can go for unconnected lookup transformation. Okay, so to pass the input value to the unconnected lookup transformation, inside the expression we have to create a variable port. There we have to write colon LKP dot unconnected lookup transformation name of input port name, right? So this is how we have to write a function inside the expression transformation to pass the input value to the unconnected lookup transformation, and then to get the output value. So in unconnected lookup transformation, we have to enable the return checkbox so that whatever return checkbox we have enabled, that port value it will return to the this one expression transformation variable port, right? To the same port. So whichever the port we have used to pass the input value to the unconnected lookup transformation, to the same port it returns the return value. Okay, so inside the expression transformation, so the variable port will use to pass the input value to the to pass the input value to the unconnected lookup transformation, we use that variable port. Inside that we have written a function. So to the same port it returns the return value. So like that we can pass the input value to the unconnected lookup transformation, and also we get the output value from unconnected lookup transformation even though there is no link, right? This is what we discussed in the last class. Okay, next. So today we'll discuss with another scenario in lookup transformation. So here we have that scenario. So if you see, there are total 5 tables here. How many tables are there? So 5 tables are there: EMP, HYD, EMP, BLR, EMP, CNI, right? And then we have a department table and the target table. So like that, there are total 5 tables are there. Total 5 tables are there. Okay. So by seeing, we can easily say that we have to join employee with the department to get the data into the target table, right? So in the target table, employee department target, here we have ENO, ENA, DNO, right? So these 3 column values will get from the employee table, and DNA, which is department name, we have in the department table. So to load the data in the target table, so we have to join employee with department, right? We have to join employee with department. Okay, so like that, here we have to join employee with department, but there are 3 employee tables here. So how we can create a mapping to join these 3 employee tables with the department and then load the data into the target table? So for that, we have to create a mapping like this. So these are not 3 different mappings. Okay, so this is called, in a single mapping, there are 3 pipelines. What we call this one? So here we have created, in a single mapping, 3 pipelines we have created. This is the first pipeline, this is second pipeline, this is third pipeline. Okay, so this is called a single mapping. In a single mapping, we have 3 pipelines here. Okay, so in this mapping, since there are 3 employee tables, 3 different employee tables, so first we have imported the employee HOD source definition, and this is a this is the employee BLR source definition, and this is the employee CNI source definition. So 3 source definitions, they are different, but the target tables are same. In the first pipeline, we have a target table. We have target definition here. The same target definition we have copy paste into the second mapping. The same target definition we have copy paste to the third mapping. Okay, because it's the same target table, we can create a copy of the target definition. What we can do, we can create a copy of the target definition. And then since we have to join employee with the department table, we can create a lookup transformation to join, employee with the department. Okay, so and we know here employee table contains more number of records, department table contains less number of records. We can create a lookup on the department table, right? So here in the first pipeline, we have created the lookup transformation on the department table, and then the joining column department number. Okay, and then from here we are taking the department name to the expression. From expression we are passing to the target definition. Okay, so here the joining condition will be based on the department number, we are joining these two. Okay, same way, second pipeline, third pipeline. So there is no change in the second pipeline and third pipeline, right? Okay, same way we have to create a mapping in the second pipeline, third pipeline also. Got it? So there are three pipelines now. Only the source definitions are different, rest everything same. So whatever here we have created in the first mapping, in the second pipeline, third pipeline, they are also same. Okay, so we have one mapping. In one mapping we have three pipelines here. Now for this mapping, how many session tasks we have to create? Do we have to create one session task or three session tasks?
Only one session task, I think so.
Exactly, only one, because this is a single mapping, right? These are not three different mappings. Okay, so here we should have to create only one session task because these are not three different mappings. This is a single mapping, right? So only one session task will create and one workflow. Okay, fine. So we have created mapping session workflow and we have started execution. As soon as we start execution of this mapping, okay, so by default, first it will start with the first pipeline of that mapping. So first pipeline, it will start execute. All the three will not execute at its time. All the three will not execute at the same time. So it will execute one after the other. First pipeline will start execute, and then second pipeline, then third pipeline. Like that, one after the other, they are going to execute. Okay, fine. Now let's say first pipeline started execution. As soon as first pipeline started execution, in the first pipeline we have a lookup transformation. We know if there is a lookup transformation, it is going to create a static cache, right? Now this lookup transformation will create a static cache with how many records? The first pipeline lookup transformation will create a static cache with how many records? Two records, because we have created the lookup transformation on this department table. Department table contains two records, 10 HR, 20 finance, like that. We have two records, so that is the reason it will create a static cache with these two records. Okay, so after creating the static cache with these two records, then source, I mean like reader, it will connect it to the source database. From this it will read the first record. Okay, so and then it will pass the department number 10. So here we have 10, right? Department number 10. So department number 10, it will pass to the lookup transformation. It will look for matching value inside the cache. Then it returns the corresponding department name and it will load into the target table first record. Same way, second record. After passing the first record, next second record, we have department number 20. 20, it will pass to the lookup transformation. As soon as lookup receives 20, it will look for the matching value inside the static cache. Okay, so yes, there is a matching value inside the static cache, then corresponding finance it will return, like that it will load the records to the target table. In the same way, third record also it will pass to the lookup. Lookup will look for matching value. Corresponding 10 department name will pass to the expression to the target, like that. So first pipeline source, it will pass three records to the lookup transformation. Okay, so lookup transformation after receiving these three records. Okay, then it will, what it will do is, it after processing all the records from source to target table, these three records, then the first pipeline, so it is going to delete the static cache. We know if there is a lookup transformation in the mapping, it will create a static cache at the beginning of the execution, and the static cache it will be deleted at the end of the execution. Now, in the first pipeline, beginning of the execution, static cache will be created with two records, and after processing EMP HYD data into the target table, since it has reached the first pipeline end of the execution, the two record static cache it got deleted automatically. Okay, first pipeline successfully executed. Next, it comes to the second pipeline. So second pipeline also we have a lookup transformation. Second pipeline lookup transformation, again it is going to create a static cache. Second pipeline we have created the lookup transformation on the same lookup table, right? Department table only we have created the lookup transformation. Now second pipeline lookup transformation, again with how many records the static cache will be created?
Records.
Two records, right? So second pipeline, again it will create a static cache with these two records, 10 HR and 20 finance. So whatever static cache created by the previous pipeline, okay, the same static cache is second pipeline also going to create, because first pipeline, second pipeline, third pipeline, in all the three pipelines we have created the lookup transformation on the same lookup table. That is the reason same cache again and again every pipeline execution it is going to be created. Okay, now the second pipeline started execution. So second pipeline, so here the lookup transformation static cache created with two records, and then second pipeline source is BLR. So from BLR source 40, 4D, 10, it will pass, first 10 it will pass to the lookup transformation. Lookup will look for matching value. Yes, there is a matching value for 10, and the corresponding department name HR that it will return to the expression, and from expression to the target it will load. Like that, the second record from the second source 5E20 also 20 it will pass to the lookup will look for matching value inside the cache, and then 20 corresponding department name it will return to the expression to the target. Like that it will load. So after loading these two records from source to target table, since the second pipeline reached end of the execution, these two records also going to be deleted. The static cache is going to be deleted. First pipeline executed successfully, a second pipeline also executed successfully. Now it comes to the third pipeline. So third pipeline, again we have the same, we have lookup transformation which is created on the same lookup table. Now again third pipeline, it is going to create a static cache with the same two records. Whatever static cache created in the first pipeline, second pipeline, the same static cache again in the third pipeline also it is going to be created. Okay, so after creating a static cache, third pipeline source is CNI. So from this 6F10, 10 it will pass to the lookup. As soon as lookup receives the input value, it will look for the matching value inside the static cache. Yes, there is a matching value, right? For 10 we have a matching value. So as soon as the matching value found, the 10 corresponding department name HR, it will pass to the expression to the target. So like that, third pipeline also third pipeline also executed successfully, and after loading the data into the target table, third pipeline whatever the static cache created at the beginning of the execution, this static cache is going to be deleted at the end of the execution. So that means now all the three pipelines executed successfully. Finally it is going to display the succeeded message. So with that the execution got completed. Okay, and one thing we have to observe here, so during execution of this mapping, since we have three pipelines, and in all the three pipelines we have lookup transformation which is created on the same lookup table, that is the reason same static cache with two records again and again created three times. Created every pipeline beginning of the execution, deleted every pipeline end of the execution. Got it? So since here we have only two records, to create a static cache with two records, it will not take much time. It will not take much time. Assume if there are 2 million records are there. This time, assume there are 2 million records are there in the lookup table. Okay, now we have 2 million records in department table, which is a lookup table. Now we have started execution of our mapping. First pipeline started execution. As soon as first pipeline started execution, lookup transformation will create a static cache. So with how many records the static cache will be created? This time, how many records?
2 million records.
2
Right.
million.
So if we have 2 million records, static cache also will be created with 2 million. So how much time it will take to create a cache with 2 million records? Will it take long time or not?
Yes, sir, it
Is
will
it
take.
going to be created within seconds? No.
No.
Right? Since we have 2 million records, it will take long time to execute. Assume it took 1 hour time. How much time it took to create a static cache with 2 million records? 1 hour. Only to create a static cache, it took 1 hour because there are 2 million records, huge data we have. So that's the reason it took, 1 hour time. Okay, fine. After creating the static cache, then reader will start reading the data from the source. Row by row, it will send it to the lookup. Lookup will look for matching value inside the static cache. Okay, and then after processing all the source data into the target table, end of the first pipeline execution, the static cache got deleted. First pipeline executed successfully. Next, it comes to the second pipeline. Second pipeline, again, we have created the lookup transformation on the same lookup table department. And again, here, this lookup transformation is going to create a static cache. So second pipeline again, with how many records it is going to create a static cache and how much time it is going to take to create a static cache here.
Same time, sir. Same records and same
Exactly.
time.
Yeah, same records with 2 million records it is going to be created. Again, it is going to take 1 hour time. Okay, so here since again we have created the lookup transformation on the same department table. So we have 2 million records. With the 2 million records cache will be created and it is going to take again 1 hour to create a same cache. Okay, after creating this cache, reader will read the record from the source table and it will pass row by row to the lookup transformation. Lookup transformation will look for the matching value inside the static cache. The matching value corresponding values, it will return to the expression to the target. Like that, row by row, it will process all the records from source to target. After processing all the records from source to target, the static cache will be deleted. Okay, next it comes to the third pipeline. Same way, here also we have created the lookup transformation on the same lookup table. Okay, so here also the same static cache it is going to be created. Again, with the 2 million records, the same static cache will be created because here also we have a lookup transformation which is created on the same lookup table. And here again it is going to create static cache with 2 million records. Again, it is going to take 1 hour time. So after creating a static cache from the source, it will process row by row. Okay, so each and every record it will send it to the lookup will look for matching value inside the static cache, and then it will return the corresponding department name to the expression to the target. So like that, all the records it will process from source to target. Then end of the execution, this static cache also going to be deleted. Now the execution got succeeded. But this time, since we have lookup table 2 million records, so each and every pipeline took 1 hour time to create a static cache. So total this mapping, okay, during the execution, how much time it took to create only static cache? Complete
Yes.
whole mapping. How much
3
time
hours.
it took to 3 hours. Okay, and in these 3 hours, so it created the same static cache again and again. Okay, so if it has created different static cache files, then fine, no issues. But the same cache it created again and again 3 times, and it took 3 hours only for the static cache, right? So this will impact on the performance. Okay, so mapping will take long time to execute. Unnecessarily, again and again, the same static cache created 3 times, and to create a static cache whole mapping took 3 hours of time. Okay, now how we can improve the performance of this mapping? So we have a mapping. So in the mapping, we have 3 pipelines. In all the 3 pipelines, we have a lookup transformations created, and every pipeline is going to create a static cache beginning of the execution, and it will be deleted at the end of the execution. In all the 3 pipelines, we have created the lookup transformation on the same lookup table. Again and again, the same static cache created, and it took 3 hours of time. In this scenario, to improve the performance of this mapping, what we will do is first pipeline, anyhow, first pipeline which would have to create a static cache with 2 million records. Okay, let's say again we have started execution of this mapping. We have 2 million records here, and the first pipeline created the static cache with 2 million records. So this static cache created at the beginning of the execution, and then it started processing the source data to the target table. After completion of loading all the source data into the target table, at the end of the first pipeline, this static cache should be deleted. But we have a property inside the lookup transformation. Okay, so we have a property inside the lookup transformation. If you go here, so there is a property called lookup cache persistent. What do we have a property here? Lookup cache persistent. So if you enable this checkbox, lookup cache persistent checkbox, if you enable and then click on apply OK. Okay, so this lookup transformation, now whatever the cache it is going to be created, so that cache we called it as a persistence cache. Okay, in the first pipeline lookup transformation, okay, by default it will create a static cache. Now this time I have enabled the lookup cache persistent checkbox in the first pipeline lookup transformation. So what persistence cache will do is same as it will also create a persistence cache at the beginning of the execution. Okay, but even though after processing all the data from source to target table, we know static cache will delete at the end of the execution of that pipeline, right? But persistence cache is not going to be deleted. Okay, so remember the difference between static cache, dynamic cache, and persistence cache. Static cache, dynamic cache, both will be created at the beginning of the execution and both will be deleted at the end of the execution. We know static cache will not recreate or it will not update during the execution, whereas the dynamic cache, as soon as any new record inserted or updated in the lookup table, dynamic cache will get updated immediately. Whereas persistence cache, it will be created at the beginning of the execution and it will not be deleted at the end of the execution. It remains same. And also during the execution, persistence cache will not recreate or it will not be updated with any of the records. Got it? Okay, remember what is persistence cache? Persistence cache will be created at the beginning of the execution. It's a copy of a lookup table with whatever the number of records are there. With those records, the persistence cache will be created and it will not be deleted at the end of the execution and it remains same and it will be there inside the Informatica server under cache directory. Okay, so that is the use of persistence cache. Fine. Now in the first pipeline lookup transformation, we have enabled the persistence cache checkbox. And the first pipeline lookup transformation created the persistence cache with 2 million records and it took 1 hour time. Okay, so even though after processing source data into the target table and it has reached the end of the execution, this persistence cache is not deleted. Okay, fine. Still we have that persistence cache inside the static cache, which is created on the department table. Okay, first pipeline completed. Next, it comes to the second pipeline. Second pipeline, we have a lookup transformation which is created on the same lookup table. Second pipeline lookup transformation, here we have not enabled the persistence cache. So if you have not enabled the persistence cache in the second pipeline, whatever the cache it is going to be created, what we can call that cache? Is it a static, dynamic or persistent? Second pipeline lookup transformation, which type of cache it is going to be created? Is it static, dynamic or persistent?
As we enable the persistent cache, that will be create persistent only.
We have not enabled the persistence cache. We have enabled the persistence cache only in the first pipeline lookup transformation.
So for the second mapping, it will be created static.
Exactly. Right. So second mapping, we should not say second mapping, we should have to say second pipeline. Okay, so second pipeline, what it will do, it will create a static cache only because we have not enabled the persistence cache in the second pipeline. So that is the reason it will create a static cache, right? Only in the first pipeline, we have enabled the persistence cache, and the first pipeline lookup transformation created the persistence cache. Okay, when it comes to the second pipeline, we have a lookup transformation which is created on the same lookup table. Okay, so second pipeline lookup transformation, it will create a static cache. But before it creates the static cache, second pipeline lookup transformation, it will go and check inside the Informatica server under cache directory. Is there any is there any cache file which is already available created on the same lookup table or not? Like that, second pipeline lookup transformation, it will check. I repeat, so second pipeline, as soon as second pipeline started execution, second pipeline lookup transformation, before it creates the static cache, it will go and check inside the Informatica server under cache directory. Is there any static cache or any of the cache file which is already created inside the same lookup table or not? Like that, it will check. Now tell me, is there any static cache file which is already created on the same lookup table available inside the Informatica server or not?
Yes, sir, it is available.
Exactly. Yes, it is available. Okay. Right? It is available, which is created by the previous pipeline lookup transformation. Where even though it is a persistence cache, this cache is created on the same lookup table. Right, so since it's already available, this second pipeline lookup transformation, before it creates the static cache, it will go and check inside the Informatica server, is there any cache which is already created on the same lookup table or not? Yes, it is already available, which is created by the previous pipeline lookup transformation. Since it's already available, second pipeline lookup transformation, again it is not going to recreate the static cache. Second pipeline, it will not recreate the static cache again. Second pipeline lookup transformation, it will reuse the existing persistence cache instead of recreating. Because the cache already available, which is created on the same lookup table, that's the reason. Again, second pipeline lookup transformation, again it is not going to create a cache which is like on the same lookup table, because it's already available. Even though that's a persistence cache, that cache created on the same department table, that's the reason second pipeline lookup transformation, again it will not recreate the static cache. Now here, since the second pipeline lookup transformation is not creating the cache, can we save 1 hour time here or not in the second pipeline? Because it's not creating, it is reusing the existing persistence cache. Can we save the time here in the second pipeline of the execution because it is not going to create any of the cache? Yes, right? So we can save the time here. Okay, so second pipeline now, lookup transformation, it will not create a cache, it will reuse the existing cache, and then reader, it will start reading the first record from the source, and it will send to the lookup. Lookup will look for matching value inside the same cache, like inside the persistence cache, which is already available. Okay, like that, second pipeline row by row, it will pass all the records from source to target. Okay, so second pipeline also execution completed. Even though second pipeline execution got completed, second pipeline, is it going to delete this cache after completion of the second pipeline? Is it going to delete that cache whatever created by the first pipeline?
No, sir.
No, right? It will not be deleted because that's a persistence cache which is created by the first pipeline. So persistence cache will not be deleted. So second pipeline, just it will use that persistence cache, and after processing source data into the target table, that persistence cache is not going to be deleted. Then second pipeline also execution completed. Next it comes to the third pipeline. Third pipeline, we have a lookup transformation which is created on the same table. Third pipeline lookup transformation also, before it creates the cache, it will go and check inside the Informatica server, is there any cache file already created on the same lookup table or not. So do we have the cache file which is created on the same lookup table? Yes, right, it is already available. Since it's already available, third pipeline lookup transformation, is it going to create a static cache or will it reuse the existing cache?
It will reuse
What?
the existing.
Right, so it will reuse the existing cache. Okay, so third pipeline also will reuse the existing cache. So here also it has saved 1 hour time. Third pipeline also not created the cache. Okay, so here also it has saved 1 hour time, and then third pipeline reader will start reading the data from the source and it will send to the lookup. Lookup will look for matching value inside the same persistence cache, and then corresponding department name it will return to the expression to the target. So like that, row by row it will process, and now all the third pipeline also got completed. And so even though all the three pipelines got completed and it has displayed the succeeded message, so still this persistence cache will be available inside the server. Even after completion of all these three pipelines also, still the persistence cache will be there inside the Informatica server. It will not be deleted. Okay, today's load is done. Today we have executed this mapping and it got succeeded. So today, since we have enabled the persistence cache, today to create a cache it took only 1 hour time. And the second and third pipeline they have not created, they have reused the existing persistence cache. And today's execution got completed. Again tomorrow, so we have to execute the same mapping tomorrow also, because tomorrow we'll get the new joinees employees information. So we'll have the latest data tomorrow in our source table. So every day we should have to execute this mapping. Okay, fine. Tomorrow we have started execution of this mapping. Tomorrow, when this mapping started execution, first it will start execution of the first pipeline. As soon as the first pipeline started execution, first pipeline we have a lookup transformation. So tomorrow, when this lookup transformation started creating the cache, before it creates the cache, as I told you, every lookup transformation, it will go and check inside the Informatica server, is there any cache file already available inside the server or not. Tomorrow, when the first pipeline started execution, it will go and check for the file inside the server. So when it checks for the cache file which is created on the same table, is it already available or not? Tomorrow, is it going to create again persistence cache or not?
Yes, sir.
Will it create or not? what will happen in the next run? Second run, beginning of the execution, what first pipeline will do? Is it going to create a static cache or persistence cache, or it will not do anything? What will happen second run at the beginning of the execution?
If same source tables are there, there is no update in source table. It will be same
Not source
persistent cache.
table. No, it doesn't matter about the source table. We are not talking about the source tables here. We are talking about the lookup. Okay, so what will happen if we execute second time? Tomorrow, when this mapping started execution, first pipeline will start execute. First pipeline, is it going to create a persistence cache or not?
No, sir, it will not create.
Exactly, it will not create. Why it will not create?
Because end of the execution, it will not delete it. The same persistent cache will be there in the server.
Yes, correct. So in the last run, when it runs, I mean, like in the previous run, the cache, the persistence cache, it deleted, and then we still have the same persistence cache. That is the reason in the next run tomorrow when it started execution. So first pipeline will not create a static cache, static or persistence cache because it's already available, which created yesterday, right? So that is the reason in second run it will not create any persistence cache again because it has not deleted. Still it is there inside the Informatica server. That is the reason second run first pipeline it will not create again. Second pipeline also will not create. Still it is there. The same cache will reuse. Third pipeline also will not recreate. Still it will reuse. So in the second run, this mapping, how much time it took to create a cache?
Less time, sir. Not a 1 hour.
How much time? Second run, how much time it took to create a cache?
Less than 1 hour.
It will take less time. Actually, the persistent cache is already available. There is no they will not take time to load all the records from the department and to the cache.
No, I am saying about how much time it will take to create a cache, not loading the data from source to target. I'm just asking about second run, the whole mapping, how much time it took to create a cache.
It will not take much time.
What is the number? Not much time means how many seconds or minutes or how many hours? I need the number. Second time when this mapping started execution, how much time it took to create a cache?
It took 0 time, sir. No.
Exactly, 0 seconds. 0. Not even less time. Not less than 1 hour. 0 seconds. Is it created second time? Second time when it started execution of the first pipeline, the first lookup transformation, is it created any of the cache?
No, sir.
No, it didn't create any cache. If it didn't create any of the cache, why it will take time? Because cache already available, which is created in the previous execution, it will be reusing the same cache. So in that scenario, why it will take time? Is it going
Yes,
to take
sir,
at least
right.
1 second? It will not take not even 1 second to create a cache because it has not created nothing. No static cache got created, no persistence cache. In any of these three pipelines, no cache has created because it's already available. It is reusing. then why it will take time? It will not take time. 0 seconds. So one thing you have to observe, if you don't enable the persistence cache in the first pipeline, earlier it took 3 hours. And then we enable the persistence cache. After enabling the persistence cache, first time it took 1 hour. Now from second run onwards, 0 seconds, nothing. So it will not take any time to create a cache. So can we improve the performance of this mapping or not? Not even single minute also it is taking to create a cache now, because already available. So every run it will be reusing the same cache. Third run, fourth run, fifth run. If it runs 100 times also, it will not take any time to create a cache because it's already available, which is created in the first execution. Okay, and that's the reason every run the same persistence cache will be reusing. That is the advantage of persistence cache. So if you don't enable the persistence cache, if it is going to be a static cache, every pipeline it will take 1 hour, and every time this mapping will take 3 hours to execute. Every day it will take 3 hours to execute of this mapping with static cache. So that's the reason we have a persistence cache. Okay, so persistence cache will be created at the beginning of the execution and it will not be deleted. And in the next run onwards, the same cache will be reused by the lookup transformation, and we can save the execution time of that mapping. Okay, next. Now, here we have a persistence cache which is created during the first run. Okay, so it took 1 hour. Let's say from last 1 week or 10 days, same cache is reusing. Okay, now customer, they have added a new department record in our source table. Let's say they have added a new department record in our source table, 30. Okay, and then accounts. So like that, in the lookup table, we have already 2 million records out of the, already there are assume there are 2 million records. Okay, so it created the persistence cache around 10 days back. From last 10 days, same persistence cache is using. Now today, they have added a new department record in the lookup table. Department is our lookup table. So in that lookup table, they have added a new department record. Okay, so this new department record, can you tell me, is it going to reflect inside our persistence cache which is created 10 days back? How this new record is going to be loaded inside the persistence cache which created around 10 days back? Now I want this record also to be there inside that persistence cache. So in the next run, is it going to create any new persistence cache because we have a new record inside the lookup table? Or during the execution, is it going to allow to insert this new record inside the persistence cache? What will happen to that new record? How that new record is going to be reflected inside the persistence cache? We know persistence cache will be created at the beginning of the execution and it will never deleted. And during the execution also, it will not allow to insert any of the records, or it will not allow to update any of the records like the static cache. But here they have added a new record and they are expecting to have that new record also inside the cache. Then what do we have to do? How that new record is going to be available inside the persistence cache? For that, there are two options. There are two options. Whenever the new records added inside the lookup table, if that new records wants to have inside the persistence cache, then we have two options. What is the first option? The first option is you have to connect to the server, Informatica server, wherever the Informatica server software is installed. Okay, so in my system, in the C drive, I have Informatica folder, and here you have to go to the server folder, right? This is the server under server. we have the inside the info we have the cache directory. This is called cache directory or cache folder, right? We have a cache here. If I open this one, a cache folder we have here. In Unix, we call this as a cache directory. Okay, so we are under cache directory now. In this location, that persistence cache file will be created. Okay, when you are practicing that time, you can see the persistence cache file here. Got it? So persistence cache file will be available inside the cache directory. Okay, what you have to do, let's say from last 10 days, we have this persistence cache file inside this folder, cache folder. So now we have a new record in the lookup table. That new record should have inside the persistence cache. For that, what we have to do is manually we have to delete the persistence cache file here from this cache directory. We have to connect it to the server. Inside the server, we have to go to the info shared directory. Inside the info shared, we have to go to the cache directory. Inside the cache directory, we have to select the persistence cache file, and manually we have to delete the file from this folder. Suppose let's say now I have deleted, I have selected and I press the delete button in the keyboard, and that file got deleted. Okay, so today I have deleted that file. Okay, fine. Now there is no persistence cache. I have deleted the file. Tomorrow, when it started execution, first pipeline of the lookup transformation, before it creates the cache, it will go and check inside the Informatica server under cache directory. So when it checks for the file here, is it available any cache file which is created at the same lookup table here now? Is it available here?
No, sir. No, sir.
Because I have deleted. Yesterday, last night, I have deleted the cache file, persistence cache file I have deleted. Since we have deleted manually, so there is no persistence cache file and no cache available. So since it is not available, the first pipeline lookup transformation, now it will start creating the persistence cache. So during the creation of the persistence cache, whatever the data present in the lookup table, with those records, the persistence cache file will be created. So this time, so do we have this 330 accounts record inside the cache file or not? Because it has created newly. Since it does not exist, created a new cache file. Cache is a copy of a lookup table. Now, since that new department, 30 department record also will get loaded inside the persistence cache file. Like that. So if there are any changes in the lookup table, so if you want, the persistence cache, that record also to be there in the persistence cache, the first option is manually we have to delete the persistence cache file, so that in the next run, the new persistence cache file will be created. So in that new persistence cache file, whatever the latest records we have added inside the lookup table, those records will get reflected. Got it? This is first option, to get the latest record inside the persistence cache file. And the second option we have to get the latest records inside the persistence cache file. What we have to do is, here we'll go to the lookup transformation, right click, edit, go to the properties. Let's say I have not deleted, assume I have not deleted, still the persistence cache file available from last 10 days. The same cache file is using, and it is there from last 10 days. Okay, so now today I want that cache file to be recreated with the latest records. So for that, what we have to do is, so here we have a property called recache from lookup source. Okay, so this recache from lookup source, only if this persistence cache is enabled, then only the recache from lookup source will be enabled. If you remove this one, you can see recache from lookup source is disabled. You cannot select anything for that. That is disabled. So recache from lookup source, it will get enabled only if we enable the persistence cache. Okay, now recache from lookup source checkbox, if you enable, you no need to delete the persistence cache file from the server. Automatically, since we have enabled the recache from the lookup source, it will recreate when in the next run, in the tomorrow's run, the first pipeline when it started execution, even though the persistence cache available inside the Informatica server, Since we have enabled the recache from lookup source, so next run, beginning of the execution, first pipeline of the execution, the persistence cache will recreate and it will replace the existing persistence cache file. Got it? It will replace the existing persistence cache file since we have enabled the recache from lookup source. This is one of the important interview questions. Okay, they will ask, tell me what is persistence cache, and then they will ask, tell me if there are any new records inserted inside the lookup table, how that new record is going to be inserted or updated inside the persistence cache. For that, you have to say there are two options. First option is we can enable, we can delete the persistence cache so that in the next run it will recreate. The second option is inside the lookup properties, we have a property recache from lookup source. If you enable that checkbox, okay, so at the beginning of the next run, the persistence cache will be recreated and it will replace the existing persistence cache with a new persistence cache file. Got it? So that is the use of this recache from lookup source. So what is meant by recache from lookup source? So at the beginning of the execution, lookup transformation, it will recreate the persistence cache. Even though it is available, again it will recreate and it will replace. Okay, so when do we have to go for this option? Only if there are any changes in the lookup table. So that time, if you want the cache to be created, instead of deleting, you can enable this checkbox so that it will replace. That's it. Okay. Fine. So if we have one more option also, third option also we have. So if you don't want to delete and if you don't want to replace, okay, the cache file, I don't want to delete from the cache directory, or I don't want to enable the recache option. I don't want to enable the recache option. I don't want to replace the, I don't want to disturb the existing cache file, persistence cache file. Then what is the third option? So the third option to create a new cache file will be, here we have cache file name prefix. Cache file name prefix. Okay, so here if you give some name like new underscore like this, if you give, so already let's say here the persistence cache file created with the name, for example, DEPT, right? Lookup table name is DEPT. Assume this is a persistence cache. Assume this is a persistence cache file which is created on the department table. Now I don't want to disturb the existing persistence cache. So if you don't want to disturb, you can give another new name, starts with any new name. Okay, so if I give like this new underscore, then what it will do is, even though the persistence cache available which is created on the same table, it will create another persistence cache file. For this persistence cache file, it will give the name like this, new underscore DEPT. Now for the same lookup table, we have two cache files here. Okay, with the different names. Okay, so whatever latest here it has created, so this will reuse. It will not reuse the old one. Whatever the latest cache file created for that lookup table, so lookup transformation will reuse the latest cache file. Okay, so this we do not, I mean, like a very rare we select this cache file name prefix. This is not required. So simply, if in a mapping, if there are multiple pipelines, and so instead of having the static cache, we can just enable the persistence cache. Recache also not required. So whenever it is required, then only we have to use recache. Otherwise, not required. Okay. So when do we have to use the persistence cache? What is the answer? What is persistence cache and when do we have to go for persistence cache means? This is also another interview question. What is persistence cache? When do we have to go for persistence cache? The answer is persistence cache will be created by the lookup transformation. It will be created at the beginning of the execution and it will not be deleted at the end of the execution. During the execution also, persistence cache will not recreate or it will not allow to insert or update any of the records. Okay, this is about persistence cache. And then when do we have to go for persistence cache? Means in a mapping, if there are multiple pipelines like this, okay, in all the pipelines, if the lookup transformation is created on the same lookup table, then the same cache again and again it will be created, and there it will take long time to execute. To improve the performance of that mapping, instead of creating the static cache again and again, in the first pipeline, if we enable the lookup cache persistent option, okay, then in the second and third pipeline, they are not going to recreate, they will be reusing the existing persistence cache. So in such scenario, we have to go for lookup cache persistent option. Clear? That's all about this persistence cache. Next, in this mapping, if you see, we have created the lookup transformations on the same lookup table, right? We know there are three pipelines. In all the three pipelines, we have created the lookup transformation on the same lookup table. Okay. Here, the lookup transformations which we have created, are these connected lookups or unconnected lookup transformations? What type of lookup transformations we have created here? Connected or unconnected?
These are the connected lookups.
Right, we know by seeing we can easily say that these are the connected lookups. Okay, so these are the connected lookup transformations. Okay, and from these lookup transformations, how many return value we are returning here? Each lookup, how many return values it is returning? How many output values we are getting from the lookup?
One output, sir.
Only one output, right? Only department name.
Yes.
Only one department name, right? So in each lookup, you can see we are passing only department number and we are getting the department name from the lookup transformation. And here also we are passing only department number and department name. Department number and department name. So each lookup is returning the single output value. So as I told you earlier in the last class we discussed, right? So if we are getting the single output value from the lookup transformation, if you are returning single output value from the lookup transformation, then which type of lookup we have to create in the mapping? Connected or unconnected?
Unconnected.
So we have to go for unconnected if you are returning a single output value. Okay, got it? Okay, fine. Now since by seeing all the three lookups are returning single output value, we have decided to create unconnected lookup transformation. Okay, fine. So if you want to create unconnected lookup transformation in this scenario, how many unconnected lookup transformations we have to create in this mapping? How many unconnected lookup transformations we have to create in this mapping? 0,
Only one,
1,
sir.
2, 3, 4. Only one is the right answer.
Yes.
Okay, so we no need to have three lookup transformations here. We can have only one unconnected lookup transformation. Let's say I'm going to remove the lookup from the third pipeline. I'm going to remove the lookup transformation from the second pipeline, and in the first pipeline I will make this as unconnected. I will remove the links from this lookup transformation. I have removed the links. Only one unconnected lookup transformation we have in this mapping now. This is unconnected lookup transformation. It is not connected from any other transformation, and it is not connected to any other transformation. Second pipeline, third pipeline, you no need to have the lookup transformation. There is no lookup in the second pipeline, and there is no lookup in the third pipeline. Okay, so now even though there are no lookup transformations in the second and third pipeline, second and third pipeline should have to use the same unconnected lookup transformation. All the three pipelines should have to use the same unconnected lookup transformation. So for that, we know how to use the unconnected lookup transformation. Inside the expression transformation, here we have to create a variable port, and then we have to write :lkp dot the unconnected lookup transformation name of CCD. Like that, in the first pipeline lookup transformation, you have to create a DNA_v variable port you have to create. In the second pipeline also you have to create a variable port like this. Third pipeline also expression you have to create a variable port. In all the three variable ports, you have to write this logic. In all the DNA_v variable port, :lkp dot, here the unconnected lookup transformation is LKP. That's the reason :lkp dot LKP of, and what's the input port we have to pass to that lookup transformation? DNO. So we have to write DNO here. So like that in the first pipeline, second pipeline, third pipeline, on all the three expression transformation, simply if you write, you can use only one unconnected instead of three connected lookup transformations. First pipeline, okay, so since we have a lookup transformation, it will create a cache and it will read the first record from the source and it will pass to the expression. Inside the expression, we have a variable port. To that variable port, we have this :lkp function. So to this function, whatever the department number we have received from the source, it will pass the department number here. Okay, as soon as it receives the department number, we know in the last class we discussed, it will start looking for this unconnected lookup transformation in the mapping. Here we have that unconnected lookup transformation. To that the transformation to this input port, whatever the department number here it has received, that department number it will pass to that the input port. Whatever here we have in the lookup transformation, only one input port will be there. To this input port, it will pass the input value from this expression variable port. And then in this lookup transformation, in all the three pipelines, we need a department name only. Only to that department name you have to enable the return checkbox. Got it? Only to this department name you have to enable the return checkbox. So that for that department number 10, corresponding department name HR, that it will return to this variable port. Now this variable port will have the department name, and that department name we have to pass to the target definition department name column we have to load. But from variable port, you cannot give the link directly to the department name, right? So what you have to do, you have to create another output port here inside the expression transformation as shown you in the last class. Okay, so DNA_vo. So here you have to pass DNA_v. So in the last class, here rate, right? So rate we have variable port. Okay, so we cannot connect rate_v to the target definition. That's the reason we have created rate_vo. There we have passed the rate_v. In the same way, here also you have to create a department name_vo, and to there we have to pass department name_v. So from this department name_vo, you have to connect it to the target definition department name. So like that, first pipeline it will execute. Next, when it comes to the second pipeline, here we do not have the lookup transformation. Directly it will pass the data to the expression. Expression we have a variable port, there we have written this function, and it will start searching for this LKP unconnected lookup transformation. To there it will pass the same department number whatever we have received from the second pipeline. For that department number, corresponding department name it will get from the cache, and it will return to the same variable port, and then that variable port value it will pass to this DNA_vo. From here, if you have connected to the target definition DNA, it will load the department name. All the other column values are same. Only department name you will get from the unconnected lookup transformation. So like that, this is the third difference between connected and unconnected lookup transformation. Okay, the third difference is in a mapping, if there are multiple pipelines, in all the three pipelines, if the lookup transformation is created on the same lookup table, instead of creating three connected lookup transformations, we can create one unconnected lookup transformation. That also gives the better performance. right? This is the third difference. Instead of 3 connected, we can create only 1 unconnected. Less number of transformations mapping will take less time to execute. So that's the reason. Got it? So the same scenario while practicing, first you create a mapping with 3 pipelines with connected lookup transformations. Okay, first time you execute and see with the static only. Do not enable persistence cache. First time the same mapping with 3 pipelines with static cache, execute and see how much time whole workflow took to execute. In workflow monitor, you can see the time, execution time of the workflow, right? So here, as soon as we start execute, if it is any executed, so let me execute and show you one. So as soon as we click on start execute, so here you can see in workflow monitor execution time. See here start time, completion time, right? You can see the difference, how much time it took here. Okay, so by seeing that, you will come to know how much time it took. So first time with static cache, this 3 pipelines mapping you have to execute and see how much time it took. Okay, and then you create another mapping or same mapping also you can use. Okay, so this time in the mapping you have to enable the persistence cache option. Second, for a second run, you enable the persistence cache in the first pipeline, save, refresh mapping inside the session task, execute and see the second time. Second time, see how much time it took. But here we have only 2 records, it will not take much time, you will not find much difference. If there are millions of records, then at that time it will make the difference. Okay, just to understand how the static cache works, just enable the persistence cache option in the first pipeline. Do not enable any of the cache and see, execute and see, and also check the persistence cache file how it is created. Okay, it will be in encrypted format. You will not read the data of the cache file. Okay, only Informatica can understand. So we cannot understand that encrypted file, cache file. Okay, after that, third mapping you have to create with unconnected lookup transformation. Same mapping, same sources, same targets. So third time you have to use for unconnected lookup transformation, execute and see whether you have got the expected output or not. Okay, so these 3 mappings you have to practice today. Fine. So in the persistence cache, and the last point here we discussed about the connected and unconnected lookup. Now unconnected lookup transformation, which type of cache it is going to be created by default? Unconnected lookup transformation, which type of cache it is going to be created?
Lookup.
By default,
cache.
static cache. We know by default it creates the static cache. Okay. Can we configure unconnected lookup transformation to create a dynamic cache? This is another interview question. Can we configure unconnected lookup transformation to create a dynamic cache? So to make this unconnected lookup as a dynamic, what do we have to do? We have to enable the dynamic cache checkbox, right? So we have to go to the properties, and here we have lookup cache dynamic lookup cache. We have to enable this checkbox. Okay, I have enabled the checkbox, then click on apply OK. As soon as we click on apply OK, a new lookup report will be created. Now this is a dynamic lookup. So we have created unconnected lookup transformation as dynamic. Okay, and then so from this unconnected lookup transformation, this time we need rate, or we need new lookup row value to be returned to the expression transformation. For that, what we have to do, we have to enable the return checkbox. So for that, we'll go here, and you can see here, if I try to enable the return checkbox, is it enabled or disabled? Is it allowing me to enable the checkbox here? Is this checkbox enabled or disabled? Return checkbox.
It is disabled, sir.
It is disabled. So that means if we create, if we make lookup transformation as unconnected, can we enable? Can we have unconnected lookup transformation as dynamic? If we enable the dynamic checkbox here under port start, it will not allow us to enable the return value. That is the reason we cannot make the unconnected lookup transformation as dynamic. We cannot use unconnected lookup transformation as dynamic. So unconnected lookup transformation always it can be static or persistent. We can also have the persistent but not the dynamic. This is another difference between connected and unconnected. Connected can be either static, dynamic or persistent, but unconnected can be only static or persistent. It should not be a dynamic. If you enable the dynamic cache checkbox in unconnected lookup transformation, all the return checkbox will be enabled. We cannot return anything from the unconnected lookup transformation if it is dynamic. That's the reason we cannot use the unconnected lookup transformation as dynamic. This is the fourth difference between connected and unconnected. So these four differences are very important, and as I told you, this is 100% interview question, the difference between connected and unconnected. So if they ask difference between connected and unconnected, without thinking you have to tell these 4 points. Okay, got it? That's all about this connected, unconnected, persistence cache, static cache, dynamics. So with that, we have done with the lookup. Still few points are there to discuss. Those points we'll discuss in the future classes. For now, with this, we have done with the lookup transformation. Okay, so that's all for the day. We will stop here today, and then tomorrow we'll start with the flat files. So we'll see how we can extract the data from a file, transform and load into a table. That's it. So that's all for the day. Thank you. We'll continue tomorrow.
Thank you, sir.